talk. I'm just going to start off with the basic logistics and then pass it over to Kamal to do the intro of our wonderful speaker. So yeah, we're just going to keep ourselves muted during the talk, and then as questions come to you, you can feel free to post them in our cohort Slack channel, and then during the Q&A, I'll call on you to ask your questions. And if you are a learner in our cohort, please feel free to keep your video on if you're comfortable. And if you are not in our first cohort of learners, we ask that you keep your videos off. So I'm not sure if we have any other people outside of the cohort joining just yet. But yeah, so welcome everyone. Good to see you all. And I'll pass it over to you for the intro, Kamal.
Thanks, Lainey. I am delighted to welcome Micah Lang to Terra. Micah is Senior Green Building Planner at the City of Vancouver. As you all know, you know how this goes now. I'll do the formal introduction and then I'll tell a little story about Micah. In his current role with the City of Vancouver, Micah is leading the development of deep carbon reduction policies and programs for existing buildings with a focus on multi-family and commercial buildings. During his time at the city, he also helped develop the zero emission buildings plan for new construction and served as the C40 city advisor for Vancouver, fostering collaboration with global cities on building retrofits. Before this, he worked as a consultant for about 10 years, assisting local governments around the world with planning and implementation of climate change mitigation programs. He holds a master's in energy and resources from UC Berkeley and a bachelor's in environmental science from the Colorado College. So Micah, my husband and I were actually housemates in Berkeley for 2.5 years. And he may come across as an unassuming and modest guy, but one day he came home in a red Porsche, which he drove around Berkeley for a while. Now you might think, this is a bit flashy, but this Porsche was about like 20 or 30 years old at that point when he bought it. And he bought it really cheap, which means it had some serious problems. But this was not an issue for Micah, because the reason he bought this car is he had decided to single-handedly gut the car and electrify it. Now, mind you, this was in the early 2000s when people were not really talking that much about electrification of transport. Tesla did not exist, and people thought maybe it's going to be fuel cells and biofuels for transport. So Micah was really ahead of his time. And so he had this pretty major project. He was not an engineer by training, but he, that did not deter him from deciding to electrify this car himself. Unfortunately, he eventually discovered that the weight of the batteries, the floor of the car, because the car was pretty old and not in great shape, the floor of the car would not be able to handle the weight of the batteries. So unfortunately, he was not able to complete this project. But for a while, we had a very sweet little Porsche parked outside our house. So Micah, there's so much I appreciate about you, your tinkering mindset and all the great work you're doing in the city of Vancouver. So without further ado, I'll hand over to you.
Great, thank you very much, Kamal. Good morning and good evening to everyone. I hope you're all doing well. Hope your families are doing well and are safe. Really happy to be with you this morning. I decided to be a floating head with Vancouver as a backdrop to give you something more interesting to look at. That's the downtown peninsula right behind my head, North Shore Mountains behind that. And if my living room is sort of straight up from where I appear in this photograph, just a short, actually if I go this way, you can almost see the pedestrian bridge that my son and I walk across to go to the park each morning. So a little slice of Vancouver for you. I'd like to begin with a traditional land acknowledgement. I'm humbly thankful to the Musqueam, the Squamish, and the Tsleil-Waututh nations whose traditional and unceded territories I live, and for their millennia of stewardship on this land. I'm a white settler working for a colonial government that has fomented and still perpetuates today racist policies that result in some of the most glaring inequalities of any North American city. And I work in the planning department, which is the architect and the keeper of these policies and regulations. So this land acknowledgement is particularly important. A lot has changed since the beginning of this year, which is the biggest understatement ever. And we can't just have the same conversations. I've been talking about greenhouse gas emission mitigation and building carbon policy for many, many years. And this year we cannot have the same conversations. And so as we struggle to make decisions to keep ourselves, our families, and our communities healthy, and we're looking for opportunities to undo the structural racism that pervades our institutions, we also are trying to put climate equity and climate justice front and center in what we do. And so I'll offer you a few rough ideas and reflections on this today and why zero carbon buildings matter more than ever. And I'm going to share with you some of the tools and technologies to create zero carbon new and existing buildings, and what we're doing in Vancouver, a few examples of what we're doing in Vancouver and how that might inspire what you're doing. I'm going to start sharing my my screen. Is that showing up for everybody? Yes, perfect. What's this? Great. And so just a little bit more of the global context. We're in a state of multiple emergencies right now. We've got a pandemic, we've got this racial inequity emergency, and we have a climate emergency. It seemed that in 2018, 2019, the world was finally awakening to the climate emergency. And now, abruptly, with the pandemic, we have a US president who is kind of flaming the fires of racism on top of centuries of oppression. We've reached this global moment of racial justice wokeness that seems to have lasting momentum. And I know wokeness is a controversial term, and I use it intentionally here as I really believe there needs to be a shift in consciousness in order to catalyze the changes that are required to address both racial inequity, the climate emergency as well. And there's a lot of inertia behind the current systems and the powers, and they're going to require broad-based change in consciousness to overcome this. The current systems regarding our built environment and land use, they're leading to both racial inequity as well as contributing to the climate emergency. Let me give you two quick examples. Right now, in heating-dominated climates, most of the utility programs out there, they're replacing 70% efficient fossil gas powered boilers and furnaces with 98% efficient fossil gas powered furnaces and boilers. This is a dead end solution that's not going to fix the climate emergency. Example two, most cities zone and build high density affordable housing on major roads constructed to code minimum standards, which leads those residents to exposure to unbearably hot indoor environments in the summer and lethal toxins from the cars and trucks from the road below. This is a blatantly racist policy in most circumstances. So it's up to all of us to identify and call out and address head on these unsustainable and inequitable practices. With some global context out of the way, here's the rest of what I'm going to cover in my chat with you today. I want to talk about framing. I'm going to talk about fossil gas. We'll orient you to the Vancouver context. We'll discuss new buildings, existing buildings, and at the end, a little bit of embodied carbon. And along the way, I'm going to, as I cover these topics, I'm going to highlight 3 aha moments for myself and in my work in recent years that have really sort of shifted my thinking, my understanding about these topics. So aha number 1, framing and the story that you tell is really more important than the substance of your message. substance is, don't get me wrong, substance is important, and I'm a scientist by training, and I really believe in substance, but the framing actually matters more. To a short story to illustrate this, in another story involving a car. In high school, shortly after having my own personal environmental awakening, my stepdad, his name is Jim, he's actually really a saint of a man for marrying into a family with 2 teenagers. He gave me the use of a truck, his 1987 Mitsubishi Mighty Max. And for those of you unaware, Mitsubishi is this massive vertically and horizontally integrated company with many lines of businesses, including mining operations in Southeast Asia, which at the time were displacing and ruining the livelihoods of thousands of indigenous people and destroying huge swaths of rainforest. So I did this to the truck because, as I was having my environmental awakening. And a few years later, I ran for the environmental officer position at my high school. I was not successful. I went to high school in a fairly conservative suburban town, and this message just did not compute. People were so confused by what I was trying to say that they just thought I was crazy. So this is an example of both the wrong message and the wrong frame. I don't have time to, oops, let me go back. I've lost a picture, but I don't have time to go into the details, but George Lakoff, he's a Berkeley neuroscientist and psychologist that explains really effectively this concept. And it really should be mandatory reading for anyone involved in government and progressive campaigns and policies. So my 16-year-old self did not understand what was happening here. And actually the vast majority of progressives fall into the same traps of not recognizing the frames that they're using to try and advance their agenda. And I think this experience in politics sort of put me off from that, but luckily I still remain really interested in policy in general. And I think through a circuitous path ended up with the city of Vancouver. So this leads me to natural gas. There's nothing natural about natural gas. 90% of natural gas in North America is fracked, which is short for hydraulic fracturing. It's severely damaging to groundwater. It's a serious global warming threat when it leaks into the atmosphere, and it leaks a lot. It leaks at the wellhead. It leaks when it's stored. It's leaked in the distribution lines from storage to the mains. It leaks from the distribution network in cities. It leaks in your home. The gas meter in homes and buildings intentionally leaks as a way to maintain balance in it. And all the major appliances that use gas, they leak. This is particularly troublesome because research in recent years has shown that we're underestimating the impact of methane. Natural gas is predominantly methane. The global warming potential on a 100-year timescale has been increased from 25 up to 33. And because it's a short-lived pollutant, using the 20-year global warming potential number of 85 is actually probably more appropriate to estimate what the short-term impact of all this leakage is going to be, as opposed to the 100-year global warming potential. And that, again, almost trebles the impact that this gas is having. And so we need to stop calling it natural. For a short while in my office, we had a swear jar for this. There's lots of better words. You can call it fossil gas or frack gas or methane. They're all good alternatives. Natural gas is a construct of the gas industry to try and create this aura of a clean burning, sort of cool fuel that solves many of our energy needs. And true, it's low cost. It provides low cost energy to many people, but at least in the North American context. But that's sort of where its benefits stop. Okay, shifting gears to Vancouver now. A few contextual slides, and this is why the conversation on fossil gas matters. Like many North American cities, most of the emissions in Vancouver come from the buildings. Across large urban areas, buildings are either number one or number two in terms of their emission impact, with transportation being the other major category. Taking a deep dive on the building sector, the bar chart on the top of the screen illustrates the contribution from new buildings, those that are constructed in any given year on an annual basis, the embodied emissions, which I'm going to get to at the end of my talk, and then existing buildings themselves. That's 1.4 million tons of carbon in the Vancouver context. And you can see in the table below, it's pretty evenly distributed among a number of different building categories. And why the fossil gas really matters in this conversation is that the orange bar is the gas and the gray bar is the electricity. You can see the disparity in cost. Electricity is really cheap in Vancouver and in British Columbia, but it's not as cheap as gas. That's cents per kilowatt hour normalized. And then you can see the carbon intensity. We're really fortunate to have a 93% renewable grid in British Columbia, and mostly from hydropower. And as a result, the greenhouse gas intensity of that energy source is more than 16 times less than gas. And so I understand that you guys heard from Amol Thadki recently, and he probably focused on the grid and national scale policies and how to introduce renewable energy to the grid and how that should be a real focus. Well, this is the complement to that. This is about electrifying buildings. And if you do those two things, you're going to be rocking and rolling from a carbon perspective in the built environment, and actually in transportation as well. And because of these carbon intensities, you have 95% of our building emissions in Vancouver are from the combustion of fossil gas inside of buildings. Okay, now a little bit more of a story. And this is getting into the new construction side. First we have a photo of the conservation house in the Canadian province of Saskatchewan, circa 1977. This was the first modern expression of passive design in sort of a modern construction sort of expression. So we've got really thick walls. We've got heat recovery. We've got renewable energy sources. This was sort of a revolutionary building from an architectural perspective at the time. Fast forward 14 years to Darmstadt in Germany, and we have the first passive house completed to the passive house standard. This is where it originated. And this building is still standing and functioning, performing flawlessly today. Coming back to Canada, in 2010, the Winter Olympic Games came to the city and to Whistler, and the Austrians offered to build a passive house, the first one certified to the international standard in Whistler as a part of the games, and then it would stay there afterwards. And so a design philosophy in modern sense that originated in Canada and was sort of codified in a standard in Germany came back just over a decade ago. And now it was a few years later, just on the heels of the City of Vancouver winning a pretty prestigious award from the World Green Building Council, recognizing the city as having the best green building policy, that myself and my colleagues in our group were sitting down and taking a look at the impact of what our building standards were having. And we were shocked to find out that actually the emissions from our new buildings were going up, and that our emissions overall were not trending down in the same way, in the way that we wanted to. In short, the standards that we are referencing, which include LEED, which some of you may have heard about, Leadership in Energy Environmental Design, as well as an energy standard called ASHRAE 90.1, which is designed by mechanical engineers and really just focuses on mechanical energy efficiency performance in buildings. These were not focused on reducing greenhouse gas emissions, nor were they focused on the performance of the building envelope. And in a heating dominated climate, that's really a huge oversight. You really need to focus on the building envelope. And so we looked around the world for some inspiration on how to fix this problem that we were having. We're just recognized as having a great green building policy, and our buildings were not performing as they should. And so this global sort of search for best practices led us to Brussels. This is a street in Brussels. Back in the start of the 2000s, early start of the 2000s, the city region buildings were among the worst performing in Europe, both in terms of energy efficiency and greenhouse gas emissions. And so the leaders in Brussels, they were looking for solutions. And what they came up with was a program called Bâtiment Exemplaire, or BATEX for short. And what they did is they offered funding of up to €100 per square meter to buildings that met a series of environmental targets, including those that were built to the Passive House standard. And so anyone could apply. They could be self-builders, it could be large corporations, private developers, even the city authority itself. And 90% of this funding went to building contractors, 10% to the developer, and this fund was available for both new construction and for renovation projects. And the Passive House standard was the standard they used to measure these, the performance of the buildings that were participating in the program. And so fast forward to 2014, the program had been in market for 8 years. It had funded the construction of 6 million square feet of buildings. More than half of these were built to the Passive House standard. It generated 320 million euro in economic activity and created over 1,200 local jobs. And Brussels had gone from one of the worst performing building stocks in Europe to one of the best. And so it was inspired by the success that Vancouver created the Zero Emission New Building Plan in 2016. And I'm going to walk you through some of the key ingredients of the success of that program. So key ingredient number one is you need to set a clear and compelling destination and path. The Passive House standard is really good for this when your starting point is poor performing envelopes, because it focuses on heat loss, specifically eliminating heat loss in buildings. You're going to typically see a 50% reduction in heat loss from buildings, 70% reduction from greenhouse gas emissions. The standard also is really great at maximizing health and comfort through the requirement of having heat recovery ventilation. This is essentially preheating fresh air from the outside with exhaust air from the inside, so that you have continuously circulating fresh air for occupants in the inside, and you're not losing all of that all that heat energy from that's built up inside of the building. Passive House is a good reference standard because it is the highest standard. It has a really rigorous certification process in order to show that a building complies. It's focused on the envelope and ventilation, which are really durable features of the building. So if you're certifying to the standard, you have more assurances that the building is going to be durable and that the greenhouse gas benefits of this building are going to be durable. This standard also really resonates with designers, builders, and the public. There's many tangible features of a Passive House building that people can see, they can understand what the benefits are. And speaking to durability as well, like these are things that builders and contractors think about when they think about quality construction. And then finally, there's a really well established network of trainers and practitioners so that the city wouldn't have to invent this. Like it's a lot of work to come up with new code and policies, but if there's an existing standard out there that's well supported, that's great to use that. And so the city has its own building code, and in 2016 we signaled that by 2025 the majority of new construction in the city of Vancouver would be zero emissions. And this was done through thermal energy use intensity targets or limits on buildings, as well as greenhouse gas intensity limits. And Passive House was used as the transformation tool to get there. Number two, key to success was feed, find, and follow the leaders. By this I mean, you need to get examples of where your end target is going constructed as soon as possible. This is important so that you build capacity, so that you learn what the barriers are, and there's examples and case studies to point to, so people can see that this will actually work. And so what we've done, a few of the things that we've done, given cash for developers to create case studies. We've given bonus floor area, which is worth a lot of money in most urban contexts. We've been doing work to simplify regulations. We've been relaxing some space height and setback limits in order to accommodate the thicker walls and mechanical equipment that might be located in places of the building that were not common in other building design conventions, and providing more flexibility to developers who build to the standard. And then number three, we focused on building industry and government capacity. A few ways that we've been doing this. Number one, through the city's rezoning process, which is basically what the majority of large new buildings go through. They must meet the next step in the code. And so developers are getting a lot of experience building to that next step before it becomes minimum requirements well in advance. Number two, we created the Zero Emission Building Exchange. This is a photo of Christian Chanfrone. He's the executive director of the Zero Emission Building Exchange in Vancouver. This was modeled after successful program in New York, the Building Energy and Emission Exchange. It's basically an industry capacity hub where it promotes best practices, hosts dialogues, does a deep dive on technical challenges associated with constructing zero carbon buildings. And it takes that pressure off of the city and is as a place of collaboration for industry to try and learn how to really advance their practice. Number three, we created modeling guidelines and professional practice standards, which is really important to demonstrate success. Number four, we offered incentives for trades training. This is really important because it's the trades who are going to be the ones actually doing the work to ensure that a building meets these standards. Four, we focused on training staff within the city. If intake officers in our development and permitting office don't understand the standard, if inspectors don't understand what a wall assembly looks like that uses exterior insulation and has advanced features to limit thermal bridging, this whole thing's going to fall apart. So we need to train our own staff as well. Number six, we are constructing all new city facilities to the Passive House standard. We need to lead through example. And so starting in 2016, every new building that we've been constructing is to the standard, including things that you don't even think about as being compatible, including a fire hall that is going to be opening up later this year. And then finally, I think really important to ensuring success and accountability within a city government perspective, the general manager of planning and our chief building official were given joint responsibility for meeting the city's building specific greenhouse gas target. This shows up in their performance review with the city manager each year. So these are sort of senior most bureaucrats in the city that are responsible for delivering on these targets. So how is it working? Just a quick snapshot. In 2015, for a multifamily building, code typical greenhouse gas intensity was on the order of 20 to 24 kilograms of carbon per meter squared per year. In 6 months from now, that will have dropped down to 6. So we're making really good progress on that front. 2016, we had one house, kind of an ugly house at that was built to the Passive House standard. Now, 4 years later, through all of those incentives and industry capacity building and support programs that I was mentioning, we've got 75 buildings that are either constructed, under construction, or are in the approvals process right now, equaling 3,600 dwelling units and more than 4.8 million square feet of constructed area. So we're moving along quite well. Okay, let's switch gears to existing buildings. And this is my baby, the existing building front right now. And this is way more complex than new construction. Existing buildings come in all shapes, forms, and sizes, all different construction areas, different materials, different code standards. And over the years, they've been altered in numerous different ways by owners, many often not complying with city regulations or state or national regulations. And so you have this huge hodgepodge of buildings, mechanical systems, and from a energy perspective and a greenhouse gas emission reduction perspective, it's a huge mess and a huge problem. Just a few common building types in Vancouver are on the screen. Since 2014, the City of Vancouver has been requiring that buildings upgrade their energy equipment or improve their energy efficiency when they come in for a building permit related to an alteration. But these have been really light touch measures. So it's they might have to do some lighting improvements. They might have to reduce air leakage. They're really light touch things, and they're not yet moving the dial on greenhouse gas emissions. So the next aha moment came in 2016. This was right after we finished the work on the zero emission new building plan. And I was asked to provide some analysis to show the business case for switching a large commercial office buildings in downtown Vancouver, as well as some large multifamily buildings, to heat pumps, to building scale heat pumps, as a alternative option to decarbonizing with biofuels, the large central steam district energy system in the city that is connected to 200 and some buildings in downtown. And to everyone's surprise, the business case for the building scale heat pumps was better. And for some buildings, in particular the large, really large commercial office buildings, there's actually a positive return on investment for doing these fuel switching projects, largely because of the fact that almost every large modern office building in a heating dominated climate in the world has simultaneous heating and cooling going on within it, and massive opportunities for heat recovery. And there's heat pumps that are really ideal for taking advantage of that. And so zero greenhouse gas emissions in buildings means heat pumps. It's a mechanical focused solution. And for those of you who may not be familiar with the term heat pump, probably most of you are, everyone knows what air conditioners are and refrigerators. These are heat pumps. They're heat pumps that work in one direction. The term heat pump is usually reserved for those pieces of equipment that have a reversing valve in them that can both heat and cool. So you can flip a switch and you can move the heat in one direction through a barrier, in the case of buildings, the wall, and then move it the opposite direction. And so in the summer, when it's hot, you can provide cooling, and in the winter, when it's cold, they can provide heating. This is actually a significant change. It's not something that's easy to do. It's not a like for like placement. There's often changes that need to be done to the heat distribution system within buildings, the terminal units, the piping. They're expensive. They cost more in most cases than their gas equivalent. In many places of the world, and this is particularly the case in Vancouver, there's limited industry capacity and know-how associated with the heat pumps, and government often gets in the way of itself and its targets. When you start strapping equipment to the sides of buildings, putting it on roofs, and putting it places that it wasn't originally designed, the city has a lot of requirements that go with that, and so it can become more complex to put in this equipment. The good news is that this is not all bad news. There's a lot of co-benefits to doing this, namely primarily indoor comfort and air quality, getting gas out of buildings, reducing fire risk and fire hazard, and in some buildings, there's actually significant energy cost savings associated with it, even in the context of Vancouver and other cities where gas is significantly cheaper on a per unit of energy than electricity. And so about a year and a half ago, as a part of the city's climate emergency declaration, Vancouver, among those 1,300 cities that I showed on the map virtually at the beginning, declared a climate emergency and set targets for buildings. The targets that were set was that by 2025, all new and replacement heating and hot water equipment will need to be zero greenhouse gas emissions. And that by 2030, we need to cut our building emissions by 50%. These are really significant targets. We're currently working on the approach for how to do this. It's going to look a lot like our zero emission new buildings plan. We're going to take a stepwise reduction in greenhouse gas limits over time. And this will give buildings clarity on where we're going with the standard and maximum flexibility in how they meet these requirements. A really quick case study to illustrate how this can be done and how it's feasible, even for a huge complex building when you just have a decade. And this case study was done voluntarily. There's a small commercial real estate company based in Vancouver called Golden Properties. They have a 26-story 1968 office building. 10 years ago, they set the goal, we want to eliminate the carbon emissions from this building. And their plan was just to focus on all the systems as they came up within their natural replacement cycle to do make the changes that were necessary in order to get to that zero carbon outcome. So this was taking a holistic view at the building, not just each individual piece of equipment. Okay, this is broken, we need to replace this. Now we got to do the boiler. Now we got to improve the lights. It was looking holistically at what needed to be done. And there's a really great case study that was done on this by ZEBEX, the Zero Emission Building Exchange, which I can connect you to for more information if you're interested. But the summary slide, which is really compelling, they were able to significantly reduce energy use in all of these areas. The ones that matter most from the greenhouse gas emission perspective, 79% reduction on electricity from their cooling plant from going to a heat capture system, a heat recovery chiller. They freed up a ton of electrical capacity in the building to enable this through a smart lighting strategy, a 73% reduction. Both of these have a positive return on investment associated with them. They dramatically decreased the domestic hot water demands, a 41% reduction, which allowed them to downsize the capacity needed for the supply of hot water, separate out those two services within the building, and use a small electric boiler to comply with that. And then the big moves in the end was putting in the heat recovery system. So this achieved an 80% reduction in natural gas. And so the final 20% reduction they are going to achieve in the upcoming years through additional optimization of that system, as they're able to get more of the waste heat recovered into that system. And this is all done with positive business case through a small building, sort of a small commercial real estate company, just looking holistically at the building. And so given enough time, we feel that this is something that many buildings as well, when given a clear target, are going to be able to accomplish. And so the owners at Golden, they say, quite eloquently, by challenging business as usual, a fully occupied existing building can become zero carbon. And I think what's also really important, that's illustrated through this case study, is that what enabled this project to be cost effective was the fact that they focused on these deep reductions and not getting to 100% zero in the first go. That's really important, because if we're going to rapidly reduce emissions on the time scale of a decade, we can't go for 100%. In this case, they got an 80% reduction, which is huge. In the years that follow, the decade that follow, as technology improves, as we get better, more efficient heat pumps, as the costs come down, that 20% will be easy to take care of. So making the big moves now, focusing on the 80% reduction is really important. And now my last couple minutes, we'll talk briefly about embodied carbon. This graphic is a little bit hard to see on your screen, but I like it because it illustrates the different components of embodied carbon. You have upfront carbon. This is from all of the extraction of raw material supply, transport, manufacturing, construction associated with buildings. You have the operational carbon, which is largely what I've been talking about up to this point. And then you have the use stage. This is the replacement, the refurbishment, repair, maintenance, use. And then finally, the end of life. At the same time that the City of Vancouver is looking at bringing forward the new policy for existing buildings, we're also going to be introducing limits on embodied carbon, in particular, the upfront carbon. The reason why this is important is, I'll show you a graph to illustrate it. These show the 60-year, over a 60-year time period, the greenhouse gas intensity per floor area of building, comparing operational and embodied carbon. Just a decade ago, the operational emissions dwarfed those of embodied. But as our buildings get more efficient, as the thermal performance improves significantly, suddenly those embodied emissions comprise half of the overall emissions from that building. And those emissions occur on day one for that building. They're the ones that occur all the way up to the point when that building is occupied. And so those matter most from the perspective of meeting our short-term greenhouse gas mitigation targets. This is a hugely rich and varied and complicated field. There's a lot of research going on, activity at the global community to establish best practice and systems for quantifying, for standardizing how the carbon emissions associated with these different processes are quantified. Don't have time to get into it now, but it's a really fascinating area and a really complicated area, and I think we're just getting started in this space in terms of regulation and also collaboration in order to reduce these emission sources. So that was a lot of information. Just briefly in summary, you need to identify, call out, and address unsustainable, inequitable, and racist practices and policies in the work that you do. It's imperative. There's not going to be successful emission reductions without addressing climate justice as well. Use the right frame for your audience. There's nothing natural about fossil gas. Set clear, compelling targets and find the leaders to help you get there. And finally, we can build zero carbon buildings today, though don't focus on 100%. You don't have to focus on that. You can, focusing on 80% or 90% is going to be actually more efficient for getting us to our targets in the long run. So thank you very much. Hopefully I've left some time for questions, and I'm happy to discuss what I presented on or anything else that you'd like to talk about.
Thanks so much, Micah. This was super informative and great to hear. I just had a question as you were talking about the retrofit case compared to the new building standard. You mentioned, I think, like 75 buildings had been worked on or completed between 2016 and 2020 for the new buildings. But do you guys have any tracking besides that one retrofit example that you shared of how many retrofit buildings are kind of coming through that pipeline currently?
We haven't formally started tracking the existing buildings yet, just because the big policy package, the retrofit strategy, we're going to be bringing forward this November.
Okay.
And so we have a lot of case studies that we've compiled just through our connections with industry. And I mean, I can share some more of those if people are interested. Some really interesting ones, including, the largest commercial office building in Western Canada that's also achieved an 80% reduction in its emissions. But I don't have good numbers to capture
Okay.
sort of holistically what's happening.
Yeah, that'll be interesting to track as they become available and as this comes onto line, I guess, because I partially asked because my partner at RMI, who works for their buildings initiative, like they had this big high level visioning where they're like, we need to be retrofitting 5 million buildings a year in the US. And right now we're like doing almost none. And it was this crazy target. And I mean, I think it was mostly to just like spark action on that front, which is incredibly important. And I think it'll be good to hear and share examples between cities in Canada and around the world and cities in the US that are doing this. So that's really interesting. Okay, sorry, I will get to the Slack questions now. Thank you all for putting them in there. Ryan, do you want to get started with your question that hasn't yet been answered?
Yeah, definitely. Thank you, Micah. This was great, actual like real world case studies. A lot of great information here. So of for example, like the 80% improvement you mentioned, how much of that comes from the initial building, whether it's the building techniques themselves or in the embedded carbon, and how much of it is ongoing, like EMSs, heat pumps, stuff they keep doing over time?
You're speaking about that snippet of a case study that I shared?
Well, just the overall improvements you see in emissions from passive.
So it's a bit different between new construction and existing buildings. On the new construction side, the vast majority of the emission reductions that we're seeing are just through better building envelopes, decreasing the thermal energy demand of these buildings for space heating. And then what that allows you to do, it gives you a lot of flexibility in how you then meet the heating needs of a building. We see some buildings getting away with just having a few small electric baseboards for their heating needs after that, which is not, traditionally people think, oh, that's a really expensive and not an efficient way to heat your home. But when your heating demand is so low, you can create a zero carbon building, and if you have renewable electricity, just through having a few small electric baseboards. On the existing building side, it's much more of a mechanical approach. Now, some buildings, you'll be able to make big improvements in envelope performance because those components will need to be renewed. We had 30 years ago, a leaky condo crisis in Vancouver because we had a bunch of condo builders from California up here who didn't understand that it rains. And so all of windows, walls, they were all getting replaced. Like I think on the order of billions of dollars of lawsuits and like other things. And so that's a huge opportunity to improve the thermal performance of buildings. And so in some cases you can get improvements on existing buildings from envelope, but most of the gains are going to be on the mechanical side.
Thanks.
Cool, thanks for that. Arthur, let's go on to your questions.
Thank you. You touched upon some of my questions, like a part of my question already, but when you were mentioning the benefit of heat pumps, what came to my mind was the developing world, and how in the developing world, usually you're not replacing a heating system, you're just adding a new one. And I was wondering if heat pumps were also good in that sense, especially if you have a energy matrix that's heavily leaning on fossil fuels or the dirty sources?
Yeah, they can still be really good, and you have to choose the best technology. So there's, like with anything, there's a whole spectrum of efficiency and performance for heat pumps. And the trick is to, as we grow the market demand and the market size for the more efficient ones, the cost will come down. There's a massive difference of impact on the local electricity grid and, a building owner's electricity bills between the sort of the cheap and cheerful heat pump that maybe operates at a coefficient of performance of, like 1.5 is single speed, and so it just turns on like with a big clunk and it's at full power, and then when it's done it turns off, and then it with creating this massive peak draw on electricity. And versus on the other end of the spectrum, you have full variable speed compressors that are, you can be in a room with it and you don't even know it turns on. Like the electrical inverter will make more noise than the actual heat pump and the fan. And those, in Japan right now, you have heat pumps, air to water heat pumps and air to air heat pumps with coefficients of performance greater than 5, some of them approaching 7. And so those, have an order, like almost an order of magnitude smaller impact on the grid. And so as the market grows, hopefully we'll get greater penetration of these high performance heat pumps, costs go down. And then you'll need less renewables to supply the demand to the grid, and less infrastructure in a building to manage those loads as well.
Thank you.
Yeah, thanks for that. Okay, let's see. We have Ha next with a question from the Slack. Ha, do you want to ask your question?
Hi, Micah. Thank you for your lecture. I just was wondering, when you talk about return on investment, and I think that like Canada and British Columbia like does have a carbon tax, right? So I was just wondering if how is that, like the carbon pricing strategy, does that change all the ROI equation, and is that part of the incentive drive for developers and existing building owners to retrofit?
Yeah, so right now the carbon tax is not high enough to play a significant role. I mean, it plays a very small role, but right now it's around $30 a ton. Like by our calculation, it would have to be up at around $250 a ton to start to drive sort of significant, as a price signal alone, drive people to switch away from gas. It's important, but it's not. It needs to be much higher for it to have a bigger impact. Like there's most of the and so I'm talking about sort of just a like for like comparison, because where the positive return on investment, the positive business case comes in, is most older buildings have really poor performing, inefficient systems in place. And so because you're having a huge leap in efficiency, you're able to overcome that cost differential between the gas and electricity, and make that up through operational savings.
Thanks for that. Let's see, I think we have 3 more questions that I see in the Slack right now. And I just want to check in with you on timing, Micah. Are you, do you need to jump off right at, I guess, 10:30, is it over there?
Yeah,
or do you have a couple?
I can continue on. I can continue on for a bit. That's fine.
Okay. We'll try and wrap this up shortly. But let me just get to Liam, then Antonis, then Shelley. Liam, go ahead.
Thanks, Lainey, and thanks, Micah. I really enjoyed the talk so far. I'm going to ask you a silly question, really, and I know that it's not a fair question, but it's what I often hear people ask, especially in the UK. So what are your thoughts or tips maybe on the classical retort that people come back with to better building regulations? So they say this will make homes more expensive, that will squeeze out the poorest people from affordable housing. Like I know it's kind of nonsense because in the UK anyway, they're already squeezed out, and that's not because of building regulations. It's because construction is an investment market and not a market for homes. But how do you kind of fight back to those kind of arguments?
Yeah, it's a good point, and I think you sort of half answered it. When we introduced the zero emission new building plan, and for each iteration, for each update that we make to the limits, we do detailed costing for how much additional is this going to cost a purchaser of of a home, an occupant if they're a renter or owner. And on the construction cost side, each of the increments has never been more than 3%. Usually it's been on the order of like 2% construction increment, which is completely lost in sort of the market-driven land economics. So, the land value is what largely drives prices here, and those little ups, those sort of ebbs and flows of the market will completely erase something as small as like 2 or 3% construction increment. And that small construction cost increment, which is actually achieved because in most of these new buildings, you're simplifying other elements of it. Like I didn't talk about it, but we eliminated some other prescriptive requirements that building developers hated in order to get to focus on the greenhouse gas emissions. But those construction increments, you recover those costs in operational savings. And that's what matters most from a low income occupant perspective, is having low utility bills. And in a well-constructed building with a really good envelope, you're going to have super low utility bills. And so that's, I think, what matters the most.
Yeah, that's a great point. Thanks for that response. And let's try and get to Antonis and Shelley, and then we'll wrap up. So Antonis, you want to go ahead?
Sure, thank you, Lainey, and thank you, Micah. This was a very insightful talk, so thanks a lot. I wanted to ask whether Vancouver had already a goal and a focus in like reducing the carbon footprint of the city for the city planning department. If you have any insights like for how to advocate for that focus if the city doesn't have it already. I'm also wondering how that correlates with like political processes, like a mayor that gets elected and that has it or doesn't have it as a focus, or like financial resources available to the city.
Yeah, that's an interesting question, and you're touching on, I think, one of the big challenges in local government and any government in general, that there's these departmental or service area silos that develop, and the carbon reduction targets or the climate work can get put into a silo or associated with a certain department or group, and others don't recognize that and aren't working towards in a cooperative manner accomplishing the carbon reduction goals. And even though Vancouver has a reputation for being quite progressive and forward thinking on this front, we still have problems with silos, and I guess the best way to address this is to do it from a top-down approach. So in our case, we were fortunate in that in the last prior to the current council and the current mayor, the previous council and mayor, they had a real focus on climate and interest in green buildings, and they hired they sort of cherry picked from the city of Chicago a green building expert to be our city manager. And so the city manager was able to send that strong direction from the top. And I mentioned in terms of what the city was doing to build capacity and show leadership, giving the general manager of planning and giving the chief building official, putting it on their performance plans, the carbon reduction targets for buildings was huge. Like they have to, it's among 5 things that show up on their performance plan. So they're working to ensure that the department is marching in a coordinated way to meet those targets. So that's massive. Like if you don't have that, it becomes much more challenging.
Cool. And Shelia, your question is pretty related. So let's go to that one and then we'll wrap up. Yeah, go ahead.
Yeah, I think, thank you, Micah. That was really interesting. So you have answered most of my questions. But I want to know, like, what are some of the interesting framing strategies in terms of communicating the cost-benefit analysis to some stakeholders like government or industries? Like, what were some of the very interesting ones? Is my voice clear?
Sorry, Shelley, I didn't quite catch the question. Could you repeat it one more time? There's a little bit of background noise.
Oh, sorry. Maybe I'll try speaking louder. So what were some of the interesting framing strategies that you used while communicating the cost-benefit analysis to the stakeholders, maybe the governments or to the industries?
Mm-hmm. Yeah, that's a good question. How you present the costs and the benefits really, it varies a lot from stakeholder to stakeholder, depending on what they value and also just how they operate as an entity. For an individual resident, like what matters to them might be like the health of their family or being comfortable inside. And so, the incremental cost for more expensive equipment might not even matter to a huge percentage of people if they're going to be getting something that's healthier and more comfortable than what they currently have. Other people will care about cost savings. Like all they care about is like operational cost savings. So if you're able to communicate benefits from that perspective, then that's really good. And then, giving another example for commercial building owners, for them, the business case is, it becomes a little bit more complicated because they completely separate their capital budgets and their operational budgets. And so if you think about it just from a simplistic energy cost savings perspective, it doesn't compute because they've completely separated those 2 budget streams. And so you have to think about it in terms of the return on investment of their capital alone and their operational savings alone, and sort of use those as those 2 silos to make the case independently, because they're managed completely different in most commercial office buildings. So yeah, it's a good point. You need to understand the stakeholders and what matters to them, and also how sort of what their own constraints and their opportunities are in terms of both financial, but also what they value.
I'm not on mute. Thanks so much. That was a great series of examples. And I actually just saw Ben's question. Ben, do you want to go ahead and ask that as our maybe final one?
Sure. Thank you so much, Micah, for the talk today. I was just interested in, obviously a lot of the oldest buildings in Vancouver, I'm sure, are protected. So how do you balance kind of the need to protect kind of heritage buildings with presumably, I presume that a lot of these buildings are probably some of the most uneconomical to retrofit. So how do you kind of balance that?
Yeah, you're right. But Vancouver is also a very young city. We have a lot of buildings that were constructed pre-1980, but we don't have a huge sort of critical mass of buildings with official heritage designation. Actually the city planners and leadership got rid of most of those buildings decades and decades ago as it went through a huge sort of construction and transformation boom. So there are not that many left. And so it becomes much easier. Like for homes, for like residential homes, we can just exclude those because there's such a small percentage of our greenhouse gas profile. And for larger buildings, we can make exceptions. And so usually what we provide is them with, they can alternative solutions, essentially, like as long as they can show that they're meeting the intent of the regulation without, they don't have to comply with the exact letter of it. And that's an approach that we've been taking for a number of years. But yeah, it's a different context than in Europe or many places where there's a huge percentage of buildings that have some sort of official heritage or character designation.
Thank you.
Yeah, this has all been really helpful, and thanks for all your good questions from everyone in our cohort. So we'll wrap up now. Kamal, is there anything you want to share or add before we conclude?
We can throw our final question at Micah, which is, as our students sort of try to find their way into climate-related work, do you have any general advice? Any thoughts on that?
There's lots of opportunities to get involved. I think I'm never I never cease to be amazed at how many new angles you can approach this work from, or new facets of this work there are. In recent years, the emergence of the importance of big data in how we manage our cities and make our decisions it's starting to be transformational, but we're just at sort of the tip of the iceberg in understanding like how to use some of these tools and approaches for making better decisions. As one example, but yeah, I think there's many different ways to make a difference, and also just thinking about going back to my comment earlier about having it's beneficial to have top-down leadership in an organization. One of the things that really strong, effective leaders on climate do is they empower individuals to identify opportunities in their own work and their own work area to make a difference. And so if you just think critically about the work that you're doing and ways that you can make a difference, and you think about it through a lens of focusing on greenhouse gas emissions, there's a lot of little things that can be identified, and sometimes those little things can turn into big things. And so I'd encourage you all just to think about how you can make a difference, like in your own in your own specific work area. And then also, there's huge emerging opportunities with regards to information technology, data, that cities are just now sort of getting on that upward swing of understanding how to use it.
Cool, thanks. Well, we have a lot of really exciting skills to plug into the climate solutions matrix. So that's great advice and perspective. And just thank you so much for being here to speak with us today and just share. We haven't heard as much about buildings as we have about electricity generation and energy more broadly. So this is great context to supplement our last week focus on energy. So thank you again. And yeah, we're really lucky to have such awesome guest speakers.
Thank you, Micah. Really appreciate it.
My pleasure.
Yeah.
Great to meet you all.
Take care.
Yeah. Take care.
Take care.
Yeah. Bye.
Thank you.
Bye-bye.
Thank you.